So let me first share my screen. Okay. Then, okay. Hello and good day to all who will be watching this video. And this video presentation is my laboratory exercise number 6 in Signal, Spectra, and Signal Processing Laboratory. So, again, I am Millard A. Lucero, 2019-333, a BSEC student of LPU Laguna. So, the title of this video and laboratory exercise is modulation. So, let us go with the instruction on how to do it. So, the objectives of this is to first amplitude modulate signals in time domain and plot its spectra, and the other one is to convolve signals in frequency domain and plot its spectra. So let us first have a quick definition of what is modulation is. So modulation is the process of varying one or more properties of a periodic waveform called the carrier signal with a separate signal called the modulation signal that typically contains information to be transmitted. So this modulation is really important, most especially in electronics and in our electronics and communication field. So just to cite a quick definition for that. So we have a two type, which are the analog modulation and digital modulation. So this these types of modulations are really important in doing this modulation. So I will be not explaining this more because it is uh, detailedly explained on our theoretical topics. So let us go with the guidelines in our laboratory activity. So we have here the following exercise will introduce you to amplitude modulation of signals using convolution. So we have here analyze the following code. So create the following function that plots the spectra of signals. So what we have here is two functions that is really essential for us to be able to plot the frequency domain and spectra of our signals. So in able to do that, so what I'm saying is without this function, we cannot be plotting our signals. So first is we have the function FFFT or myFFT underscore plot function. So this is a function that plots the spectra of the signal. Then the other one is the myConv, which function is to plot the convolution of a spectra of two signals. So first, we have to do this and save this to our GNU Octave. So we have to copy first this. And let us open our Octave. Okay, let us wait. Then on our editor, we should plot the first function. So it is really important. My copy is incomplete. Okay, so this is up to this point. This will serve as the my FFT plot. So for us to be able to plot the spectra of the signal. So, okay, so let us save this first. So what is important here is to save so I will be saving it into OE number 6. What is important here is that the file name should be same, just like the our just like what we have here, my FFT underscore plot. So this will be the first function, then the load path. Then we will be having a new script here for the second function. So up to this point. So, okay, then save this, and we should Say this as my underscore conv. So add the directory. Okay. So what we have here in both functions. So the first one is the myFFT underscore plot. So this function that plots the spectrum of the signal. So attached to it or encodes with it is the window length, transform length, the DFT, and rearrange Y values and zero-centered frequency range and zero-centered power. Okay. So the other one is the myConv. So this will serve as the function that plots the convolution spectra of the two signals. So we have here also the window length, transform length, the DFT, rearrange Y values, series-centered power, windows length, transform length, rearrange Y values, series-centered power, and so on. So let us go with the first activity. So we should be explain the output for each of the spectral plots of the following exercises. So first, we have here the number 1. So we will be analyzing the amplitude modulation with and without using the convolution. So let us first analyze this set of programs or codes. So we have here the fs is equal to 4,000, which functions as the sample frequency in terms of hertz, and the time. This is the time parameters. So in terms of 10-second sample. Then the first signal, which is in 15 and 40 hertz components. Then the other signal in terms of sign, and the V, which is the convolution of these two signals. So this is the product of the X and C variable that we have, or the two signals that we have. So the other codes. So we have here the first figure. So we have here 3 3 3. So basically we will be having here a 3 rows with a 1 column with their position. So this is just plotting the T and X values. The second one is the T and C values, and the T and B values, or the convolution. Then this first figure explains shows the time domain of this modulation. Then the other figures, or our figure number 2 will shows the spectra frequency domain image of our amplitude modulation convolution. Okay, so let us copy this and let us see what will be the image of this set of programs or codes. So copy, then so let us be saving this. Okay, so we will be naming this as number 1. Then save. Then add the directory, to load the path. So let us wait. I'm sorry, my PC is takes time to. Okay, so what we have here in figure number 1 is what I've set the image of the time domain, and the figure number 2 shows the spectra in frequency domain. So the first one is the T and X values. Then the second one will be the T and C values, and the third one is the multiplied of those, the multiply of T and B. So the multiplied of the two signals. Then the other one is in frequency domain. So the last is the convolution of the signals. Okay. So this shows the frequency and time domain and the frequency domain. So let us go. Let me first close this. Let us go with the figure of our item number 2. So amplitude modulation of an audio signal. So we will be having here, uh, we will be doing and plotting our own created voice or signal. Okay, so we will just modify this because load handle is cannot be applicable or cannot be recognized by our GNU Octave. So we will be modifying this into first. Let us identify a variable. So I will be having an fs with its frequency. So I will be using 1,000 10,000 frequency. Then next, um, this is for to be able to record our voice or signal, our voice or our audio. So I will be having here the time duration and the variable of the frequency. So fs is equal to, you can also write 10,000 here if you want, but it is also acceptable. So we will be analyzing this. So this t is the time parameters, then y is equal to y prime, the c is the cosine, the v is y nu multiplied to the c. Then what we have here is the figure up to this point. So we will be having here also at 3 rows, 1 column, and plotting the ty nu and the tc and the tb. Then the second one is, this figure 1 shows just like our previous item number 1. So we will be having here in time domain. Then the other one, our figure number 2, we will be having the frequency domain. So this is a 4 rows 1 column plot. Okay, so let us copy this and see what will be our plot image. Okay, and also after running this, we will use another script. Okay, so after I play this, after I save this one, so automatically the program will run. So we have to be recording our own voice. So okay, run. Sorry. Save this first pala. Then I will be naming this as 2. Okay, so I will be saying I am Mered A. Lucero. Okay. I am Mellard A. Lucero. I am Mellard A. Lucero. Okay. So voice are processing. Signals are processing. So this is the image of what our audio looks like. So in first figure, it is in time domain. Then the second one is in frequency domain. So okay, that was all. And thank you very much for watching. And sorry, thank you very much for watching. And I hope you have learned a lot from this video. And thank you very much. God bless to all and keep safe. Maraming salamat po.